There is a small but very loud community claiming the Earth is flat, and that the sun and the moon are very close. This model poses a big problem for how the sun is setting. The model claimed the moon and the sun are 50 kilometers in diameter, and orbit the North Pole at an altitude of about 5,000 kilometers. In this model the sun will never be more than 33,000 kilometers away, and never below about 10 degrees elevation. Before we take a closer look at sunset on a flat Earth, we have to establish some facts. The sun's apparent diameter vary from 31 arc minutes 45 seconds to 32 arc minutes 53 seconds due to the elliptic path of the Earth around the sun. That is a variation of about 1 arc minute, or 1/60th of a degree, or about 3%. The sun can however appear larger as it sets above the horizon. This is not due to refraction, but the phenomenon called Ponzo illusion, where the sun on the horizon appear to be larger than when it is higher in the sky. Sometimes haze and clouds can also make it difficult to make out the exact size, but if we measure accurately we find that it is the same diameter. Measuring the apparent size of the sun with a normal camera is almost impossible. First of all you need to use a special sun filter, of around 16.5 f-stops, or ND 100,000. The ND filter will make it possible to see the exact diameter of the sun. Second, remember that popular consumer cameras like, say, the Nikon P900, actually only have a 350mm lens. It is due to the tiny sensor of 1/2.3 inch we get the 2000mm equivalent zoom. That's half the size of the sensor in a DJI Pocket 2, and 1/4 the resolution. To achieve any quality the camera uses computational correction to compensate for distortion and dispersion of light due to poor quality lenses. Just refocusing will cause a shift in zoom in lenses like this. By all means, it is a decent consumer camera, but it is not an optical instrument. To get a lens with this zoom range, we are talking about broadcast quality lenses costing a couple of $100,000. What you should be using is of course a heliometer, or a small, good quality celestial telescope if you want to take pictures. We are going to look at the sun from Mexico, the 21st of September at noon, and then at 1700 hours. This is 1 hour before sunset when the sun is at 10 degree elevation, but we will also look at the sun as it sets. Then, when it is 5 p.m. in Mexico it is midnight in Longyearbyen on Svalbard in Norway, where the sun should be at -11 degrees, in other words below the horizon. Finally we move on to midnight the 22nd of December in Longyearbyen, when the sun should be at -35 degrees. We try these observations on the flat Earth model. The first observation is made in Tapachula in Mexico at noon in September, where we find the sun at 75.5 degrees. Calculated distance is 6,617 kilometers and apparent size of the sun is 26 arc minutes. We use the calculated height of the sun from this observation for the rest of these observations. We then move on to 5 p.m. According to this model the sun is now set, even though it doesn't set for another hour. Anyway, in this observation according to the model, we find the sun at 40 degrees elevation, a distance to the sun of 9,974 kilometers and apparent size of 17 arc minutes. At 6:30 p.m. the sun should be below the horizon. In this model we find the sun at 33 degrees elevation, at 11,683 kilometers distance, which give an apparent size of almost 15 arc minutes. But look, the azimuth of the sun is 308 degrees. According to real-world observations the sun sets at 270 degrees. At 5 p.m. in Mexico, it is midnight at Svalbard and the sun should not be visible. In this model we find the sun at 28 degrees elevation. The distance to the sun is calculated at 13,641 kilometers. Apparent size of the sun is about 12.5 arc minutes. The polar night in Longyearbyen lasts from the 26th of October to the 23rd of February. At midnight the 22nd of December the sun should be 35 degrees below the horizon. In this model we find the sun at 23 degrees elevation and a calculated distance of 15,979 kilometers. The apparent size of the sun is almost 11 arc minutes. None of the observations match real-world observations, so this model don't hold much promise. The claim is that the sun sets due to perspective, apparent size, and some unexplained refraction. So, the sun is set and not visible from Mexico at 40 degrees elevation at a distance of 9,974 kilometers? Why don't this affect the stars? Why are they visible at the same distance? On a globe, however, the sunset just work, because of reasons. The apparent size of the sun will never be less than 7.5 arc minutes, or about 6 times bigger than Venus at its closest. The sun will never be below 10 degrees in this model. At this height, refraction will be less than 1/10 of a degree. How can the sun be at 23 degrees elevation at midnight midwinter? Contrary to observation, the sun vary greatly in size. How does sunset actually happen on a flat Earth?